Hello, okay, so here we have a Panasonic, I think it's a 32-inch television model TH-L32B6Z, and does not turn on. Blinking red light. Let's have a look. So we get a somewhat regular blink of the power light. It rapidly flashed green when I plugged it in and went off immediately, and now it's blinking red. No image, no audio, totally dead. Unlucky for me, and hopefully not too unlucky for the oh no, someone's been in this before. Missing screws. Let's hope it's not being butchered. I wonder if the arrow is to remind them what way to pull the power cord to get it out. Hey, cool! Comes with a bag of spare parts. Might be handy. If only all TVs had spare parts. Alright, so back left we have power supply, and we have that's gonna be backlight. Doesn't have much of a backlight, just one wire going off to, or one connector, two wires going off to backlight. It's interesting. I wonder what they're running, if it's LED or probably, actually I'm going to say it's LED. Little LED current regulator, power supply, cables, main board, and LCD control. Very, very, very simplistic. Nothing to them anymore. So what we need to see is, do we have rails on here? There must be at least our standby / 5-volt line. No markings on the PCB by the connectors. So if we're lucky, there we go. What does that say? 16 volt there. That's, I think, possibly down to our backlight. But we'll flip the board over and just see if it's got any markings that will help us. Sadly, no markings on the underside of the board, so let's go ahead and start taking some measurements and see if anything looks somewhat reasonable. Okay, we are all plugged in. We have our red flashing light, and we will see what we've got running up this connector here. So, you know, when I do that, you want to keep fingers away from these metal heat sinks. They can be live sometimes, yeah, so gotta watch that. It looks like a main switching regulator. There's our power transformer. We've got our mains coming in through here. This is our live side. Sorry, okay, our switching transistors over this side. This is actually secondary. So what have we got coming off the rectifier? 13 volts. Sorry, the regulator there. No, rectifier, it's a twin diode pack. Let's just run up this plug here. So we've got nothing. Am I even getting into the pins? I don't think I am. Oh no, maybe. Stand by, I need a better connection. Right, I'll just put some insulation tape along here so I can get my probe down the side and probe the back of this connector without shorting it out against the heatsink. So we're going to have definitely nothing on the first one. No. 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 There's our 5 volt. 5.3. That's alright. Nothing. Nothing. 3.2. So that's a good start. 3.2. Nothing. No, 3.2 still. Nothing. 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 A whole lot of nothing, but I've got 5 and 3.2, which is about all I'd expect for the main board. Still blinking red light. What if we see if it's half intelligent? It must be somewhat intelligent. If it's blinking a red light, the brain must be working. If you ever want to know if your remote is working, just point it at the camera on your phone and you'll be able to see the transmitter LED infrared diode blinking away, so you know that it's actually working. Just a little trick for you there. So here we are. These are the two connectors here, just to give you an idea where we're looking. And this appears to be 2 MOSFETs. This one seems to be power control for powering on the motherboard. Like, I think it's turned on by the motherboard. And this one is our backlight power feed. And so the motherboard will turn this on, which will pass a voltage down to our backlight connector. So that is fed from this capacitor, which has a rating of 35 volts on it. So I think we need to double check that rail and see if that's being generated as well. So we want to see if we have some decent voltage at this 35 volt cap. This one's a 25 volt cap, but that's on our 16 volt rail, I think. So plug it in, and what do we get? 24 volts. So I suppose that's about right. And kind of fluctuating now. It's gone into fault mode. It's not, maybe it's just not under enough load for regulation. But 24 is not too bad. Now it's got the leads jammed in the output of the LED driver. So let's see what we get if it's even trying to turn on the LEDs. No, she doesn't like that. Very, very brief activity. I'm wondering if there's maybe an overload on the LED strip, so it's shutting down almost immediately. So maybe unplug the LED strip and see what happens. So the LED strip's unplugged, so we'll just see what effect, if any, that has on the overall thing. We have our flashing light, green. We have our steady green light. No, still going into fault. Let's have a look at our LED driver board a bit closer. I still think it's not getting feedback from the board, so it's shutting down because there's no backlight. We have a fuse right beside the connector, so let's check that. That looks alright. We have a couple of switching transistors. Now I think, as far as I understand, and I'm probably wrong, that this will actually switch up our 25 volts to something a lot higher to pass current through the LEDs because there's so many of them. So let's just check our semis there and go to diode. That looks normal. Gate, drain, gate source. If that is gate source, I don't think it is. That might actually be to the same. Okay, they're joined together. Some kind of rectifier there. So that's our rectifier. So what have we got there? So that one's alright. And this has got to be our switching transistor. Oh, there's our reverse diode. And this looks like possibly a P channel FET. I'm not really getting any readings the other way. So that looks alright, there's no shorts at least. Just a very quick look on Google says that the blinking red light is a flashing code. You probably all know this. Probably should have looked that up to start with, but it only blinks once every so often, so that's number one, code number one, which means backlight inverter circuit, which is where I was headed anyway. It just seemed to make sense. So I had a closer look at the board, and there's markings on it that tell us what pin does what on the connector. There's some other markings around the chip that operates it. So let's check those and make sure that they are what they should be, or see if one's missing. That'll probably point to the problem. So just over to the top of the connector there's a little printout of what pins have what signals, and all we've got is power, ground, status, and on off. So I'm not sure what they're doing for brightness control. Maybe it's just how much they drive the LCD to let the light through or not let the light through perhaps. But anyway, it's either on, off, or I don't know what the status line will give, but either a high for good and a low for bad. Over here, these pins have got UVLO, which I guess is under voltage lockout. That may mean that if this isn't generating the high enough voltage for the LEDs, it won't turn the FET on to pass it through, I suppose. There's also supply voltage. There's STB standby, VCCs, our power. There's a test pad for gate, so we could probably scope that. There's OVP, over voltage protection test pad, and another test pad marked ADIM. So okay, there's some kind of dimming control and whatnot, but there's no or is there? Okay, yep, I missed it. At the bottom of the list there's a pin that is brightness control, so there we go. So let's start probing at those and see what happens. Alright, you got a good view of the meter, hopefully. Hang on, let me get in position. We'll get my ground pin, we'll get the power lead. Where did I put that? And chuck that in. Alright, so we've got our input power, connect the lead, lights blinking, input voltage says 24. got our pin here, which is 3.2, and that goes to nothing, so that must be our on command. That's pin number 14, 13, 12. That's on off, so that's correct. Needs to be 3 to turn on this board. Then we've got our brightness control. So if I push the power button, does that make our red light go off? Yep, I can use the power button to cycle. So here we have our dimming control at 3.2 volts as well, interestingly enough. But I need to look at the status pin. So what's that doing? Status is 11. 14, 13, 12, 11. So at the moment status is 3.2. Seems to be staying at 3. Oh, it's flickering. Didn't like that, did it? It sort of flickered like maybe it was trying to start. And each time it tried to start, it dipped. My meter might be too slow to pick it up if it's dipping completely to ground. But there's a chance it will be. We should probably look at the scope. But the 3 volts on the dimming control might even be a pulse width modulated signal. That's, again, it's too fast for the meter to pick up, so it averages out to 3 volts. So we have our status. Let's have a look at, make sure we've got power to our control IC on the board here. So I'm going for the pad marked VCC. Turn it on. That's 11.6. So what is our, what's on there? I don't know what that is, 5 volts. That's something else, doesn't really say. TC 554. There's a pin mark standby. Which is, there we go. So standby is 0. Oh, that's flicking. It's flicking off, on. Interestingly. I wonder why the standby is flicking off and on. Just checking for heat. I don't feel anything. Okay. Now I'm not sure if that's an input or an output, but it was flicking about the same as our status signal. So what's our UVLO under voltage lockout pin doing? That's 3.5. It's not fluctuating. But it does stay high while it's on. So I'm not too sure what that means. Maybe I need a data sheet on this chip, I think. I won't worry about the dimming control. And then LED 1, which is probably going to have nothing on it. Oh yeah, 18. Okay, so that's flicking up, down, up, down. Interesting. So that's our LED output voltage, I think. Possibly. Although here's our marking on the board that says V out. So if I probe V out and turn it on, what do we get? 56, it jumped. 34. I think I need a scope. Let's just put this into high voltage, we'll just set the range so it doesn't have to auto range and it might catch it a bit better. On 23, 90, 24, 90. So it is generating a high voltage, but it's dropping off real quick. I think our LED string is probably bad and it's sensing an excessive current draw. Unfortunately, I don't have a power supply big enough to power it manually and just see what lights up or what doesn't light up. It may be sensing a too low a current draw even, but anyway, at this point I may have to disassemble the screen and start checking individual LEDs. But the fact that it's responding to button pushes, it's blinking its light, and all the voltage rails are present, we can safely assume its brain is working and the power supplies are fine. I'm pretty sure that this is a backlight issue, and I don't believe that it's the driver board. So I'm going to take the display apart. I've removed the front edge trim. It was basically hanging off. There's a few small metal clips around the side you have to remove. Now I removed the main board and speakers because they were screwed to the front bezel as well. Just getting in the brackets are getting in the way, and just make it a bit easier. I may not have had to remove that. I've left the power board on there. That's all going to lift up as part of the one back section. The LCD control board, the flex will have to come off. This seems to be taped or something to the bottom as well as screwed. It's stuck on there. I'm not going to lift it really hard. I'll probably snap it. No point, it can stay on there as well. Okay, the screws are undone and the thin strips that run around the edge are removed, and if I lift this up, the panel should just fall out. The strips around the edge are what hold the panel in, so if I lift that up we should be left with just a panel, hopefully in one piece. Just got to watch there's a board that runs along the top edge. Well, it's upside down, it's the bottom edge. That connects to the LCD, so we don't want to have that flex too much or damage the connections to the panel. But, that is carried. Probably separate that if possible. Just leave that hanging out. There we go. Let's see if I can get you a better shot of that. So that's this strip here that has the flex that goes to the panel itself and has the ribbon cable to the control board. So we'll just have that separate, take it off. It was clipped in here, so remove that so there's no stress on it, and lift it off. There we go. Now to remove the diffuser, it looks like these clips hold the plastic edging which is holding in the diffuser, which is in front of our LED strips, so we shall unclip those, just pull out and lift up, and it should all let go in theory. And the panel sheets are held in position via these little tags. They sit over, so looks like that's all going to come off as one stack. Or at least one layer is. The other layer feels like it's okay, we'll get that off afterwards. We'll take the top layers off. And the slightest imperfection in these shows up on screen, so be careful with them. I've got a much thicker piece of plastic. And then we have our LEDs. Look at all these little bubbles. LED bubbles. Yeah, a bit of work goes into getting the nice dispersing of the light to make it all uniform across the screen. Now I wonder if you'd be able to tell just by looking at one, like do they burn out? Do they get a black spot in them? I've not ever done any of these. But they look a bit special, their little covers on top. And it looks like with our 3 rows, our main connector must split into these 3 here, so let's dig a little deeper. So we'll put some power on each strip and see if we can make them light up. We've got so 25 volts on the bench supply. I don't know what they should be run at, but unplug the center one so that it can't backfeed through to the controller, but it's probably no big deal. And if we just put power on the pins, there we go, we've got a row of lights there with one out up at the far end. The center strip has no light at all, and the bottom strip has got one LED out at this end. And it kind of looks like some of them are slightly yellow. That strip is a whole lot dimmer. It's pulling 50 milliamps, and this strip is pulling half an amp. So yeah, go figure. But I mean, if they're cheap enough, it would be worth just replacing all 3 strips, I guess. I just need to try and find some. Okay, well, that was a shambles. It works. It works just fine. We have our backlight on. No problem there. If I reach around the back and push a button, we get a menu. There we go. Yeah. I got home from work and raced into it and forgot to turn the camera on, but I assure you, here's the old LED strips, all 3 of them. Just put a flat screwdriver or something under one end and start prying up, and they lift up. They're double-sided tape down, but they lift up quite easily. I started using hot air, but it's really not necessarily, just lift them up. I mean, they're stuffed anyway. If you fold them in half, it doesn't really matter, but there you go. New strips in, and it all works. I made a complete rookie mistake. I don't know. When the first time I was filming this before I ordered the strips and we went over it, I must have switched the panel, and I actually installed it in reverse with the back half facing out, and I had no picture, and I thought maybe I'd destroyed the panel somehow. It looked mint condition. There was no physical damage to the strip on it. The flex going to it looked fine, but I had no picture, and it finally dawned on me that I'd actually put it in backwards. So the flex coming over the top of the LCD was upside down in the connector. So yeah, don't put your screen on backwards. That was annoying. But yeah, okay, there we go. LED strips replaced, all going well. Hope that helps you identify your backlight issues you might be having. Thanks for watching, and check it again soon.